Today we're going to talk about shifting quadratic functions. And if you did the Desmos activity yesterday, the first three, let's see, 2, 3, 4, 5, 6, 7, 8, 9, were really the part that we're going to focus in on today. And what happens when you shift quadratic is you're going to move it right, you're going to move it left, you're going to move it up, you're going to move it down. There's other types of transformations that we can do to a quadratic, and other graphs for that matter as well. We can reflect the graph, which we'll talk about soon. Rotating, we're not going to really deal with rotating. Dilating, which is to stretch or compress, we'll deal with that eventually as well. But today we're just going to concentrate on the shifting, which is moving the graph right, left, up, and down. If we look at our first picture here, it says consider the function y equals x squared. We want to create a graph of this function that's 2 units up. So before we do that, let's just put a couple points on this graph. For instance, our vertex right there is at 0, 0. And we have a point of 1, 1. We also have a point of 2, 4. We have a point of negative 1, positive 1, and negative 2, positive 4. Just to pick out a couple of points to work with, because like I say, our first idea here is to move our graph up 2 spaces. So we're going to take the vertex and we're going to move it up 2 spaces. So now we're going to point here. We're going to do the same thing to all of those other points that we just put on. So 1, 1 is going to move up 2 spaces. And 2, 4 is going to move up 2 spaces. And negative 1, 1 is going to move up 2 spaces. And negative 2, 4 is going to move up 2 spaces. And there we get our new picture. We plotted the points. Now let's write this graph, or write the equation of this red graph. And what it is it's y equals x squared. But since we moved it up 2, we're going to add 2 to the function. That's the equation of y equals x squared, or y equals x squared plus 2 is the equation of that red graph. Now it's hidden behind my y here, but look at the point 1, 1 on the graph of f of x. So it's a purple point. And then where is it now that we moved it up? Well, where is it now? It's at the value of 1, 3. And what's happening to our point here when we move it up? What do you notice about the x and y coordinates? Well, to save a little bit of time, I typed this in, the answer to that. If you compare, what happens is that the x values are both 1s. But in our original point, the y value was 1, and now the y value is 3. And what happens is that the x value stays the same, and the y value changes. Give you a minute to write that down. So now, if we look at part C here, it says create a graph g of x that's 2 units left from the given graph. Not the red graph, the original graph that we're given. So you may want to switch colors here. And let's move our graph 2 spaces to the left. So 0, 0 is going to move here. And 1, 1 is going to move here. And 2, 4 is going to move here. Negative 1, 1 was a point. We're moving it 2 spaces to the left, and now it goes here. And negative 2, 4 is going to go 2 spaces to the left. And now we have a new quadratic. And if you took the time to do the Desmos activity yesterday, you maybe have some idea of what the equation is here. It's y equals x plus 2 quantity squared. And after we know the equation, and we'll talk a little bit more about the equation in a few minutes, but if you look at the point -2, 4 on our graph, that's from the original graph, and then what's the point now that we moved it to the left? Well, the point now is -4, 4. And what I hope that you're noticing is that it was -2 for the x value, and then it became -4. So the x values are changing. The y value of the original point is 4, but the new y value point is still 4. So in this case, the y value stayed the same, but the x value changes. And that's what happens when we're moving the graph left. Give you a minute to write that down. And here's kind of a summary. It's kind of a summary of what happens, and it kind of goes along with our Desmos activity that we did yesterday. And that is, if we add something to our function, it's going to move our graph up. If we move downward on our function, then, since we added c to move up, we must have to subtract some value to move it down. The second graph here, we moved left, and what happens is, so I'm going to start at the second blank here, when we moved left, our format was that we added something. We had on our equation, we had x plus 2 in our parentheses. So when we move left, we're adding, and then going back to the first blank, that must mean that when we move right, we're subtracting. It seems counterintuitive, but it's correct. And if you take out that second piece of paper that I handed out, it looks like this. Let's fill in the first 4 today of the different transformations. And again, remember what we're working with. We're only working with up, down, right, left. Well, if we have a function, and we add something, add c or something to it, what the process is, or what happens is that we're moving it up c units. That's the transformation. That's how the graph changes. So the example that I gave off to the side is y equals x squared plus 2. We would be moving up 2. And again, if we add something to the function, we're moving up, which means that if we subtract something from the function, we move down. Well, f of x plus c, the plus c is inside the function, means that we're going to move our graph left c units. And if we subtract c, then we're going to be moving our graph right c units. In this case, right 2 units. It's something that a class a couple years ago taught me, at least in terms of their thinking, that might work for you. is that when we're moving up or down, that value is outside of the function. We've got f of x, that's the function, and then we add something. Or f of x minus something, that's the function. So I don't know if that helps, but I want to throw that out there because it might work for a couple of you. And when we're moving right and left, that's inside the function. It's f parentheses x plus c. The plus c is right inside that parentheses, so we consider that an inside the function. And again, that might help for some of you and that might not help for some of you. So let's flip back to our notes and turn it over to the other side. And what we're going to do is we're going to come up with the transformations, and then we're going to draw the graph. And on this graph, I'm going to graph it without a calculator. Right now you can use a calculator, but I want to show you the pattern because eventually we're going to get to a point where you are not going to be able to use a calculator. So I'm hoping that if I show you the pattern throughout the units, then maybe it won't be so difficult when we get to the actual graphing of the function. But before we get there, we need to identify the vertex of this function. And when we look at it, we see that it's in vertex form already. And what happens is we're going to change the sign, and we're going to keep the sign. -2, -7. Well, I know that it says x plus 2. The plus 2 is inside the function. And we're going to go left 2. And if you have this idea of in your head of the change the sign, keep the sign, then you probably can identify pretty quickly that it is left 2. Because, oh, I've got to change that sign. That means I have to go left. And then the -7 is down 7. Is our other transformation. And then we're going to come over here and graph. Again, you can use your calculator. I'm not going to. We're going to start with -2, -7. And all the points that I graph are coming from this point, starting at that point. The pattern on a quadratic is from the vertex. We go one space to the right and one up. From the vertex, we go 2 spaces to the right and 4 up. The graph is symmetric. From the vertex, we go 1 space to the left and 1 up. And we go 2 spaces to the left and 4 up. And there's our picture. Again, you can type it into your calculator. Look at the table. I want to show you the pattern so you kind of are familiar with that. Letter B. Y equals x minus 5 squared plus 2. What's the vertex or the turning point? 5, 2. Change the sign, keep the sign. -5 is inside of the parentheses. That's going to tell us to go right 5. Plus 2 is outside. It's going to be up 2. Now we've done the transformations, we've done the vertex. Let's come over here and draw our picture. Starting at 5, 2. Again, when we draw the picture, everything goes back to the vertex. From the vertex, I'm going to go 1 space to the right and 1 up. From the vertex, I'm going to go 2 spaces to the right and 1, 2, 3, 4 up. From the vertex, I'm going to go 1 space to the left and 1 up. And 2 spaces to the left and 4 up. And there's our picture. See if you can come up with the vertex before me, and a couple of you already are. But if we take a look at this one here, our vertex is negative 6, 4. Change the sign, keep the sign. Since it's x plus 6, that means we're going to go left 6. And if you can identify the vertex, I bet you can figure that out. And plus 4 is up 4. And when we come over here and we draw our picture, I want to show you how to do that. Negative 6, positive 4. And once again, from that point, we went 1 space to the right and 1 up. 2 spaces to the right and 4 up. You're still going from the vertex. 1 space to the left and 1 up. 2 spaces to the left and 4 up. And there's a picture. To go backwards for a moment, what's the domain of this function? Negative infinity. Infinity. Our range is not. Negative infinity to positive infinity does mean all real numbers. Our range. Do we have a high point? Do we have a low point on the graph? We have a low point on the graph in this case. It's at 4. And then our graph is going to continue to go up and up and up and up. So it's going to be 4 to infinity. Infinity always has a parenthesis. Because the 4 is on the graph, we're going to have a bracket. And I know, we didn't ask for that, but I want that to stay in your mind, the domain and the range. If we look at letter D, once again, we want to come up with the vertex. Well, change the sign, keep the sign. Change the sign, keep the sign. Knowing that pattern, that helps us to identify whether we move right, down, up, left. And we actually did move right 2 spaces. And we moved down 3 spaces. And once we identify those facts, then we're going to put this on our graph here. And me showing the pattern. And it is right 2, down 3. There's our vertex. That's our turning point. From that point, we go 1 space to the right and 1 up. 2 spaces to the right and 1, 2, 3, 4 up. Again, you're counting from the vertex. So we go 1 space to the left and 1 up. 2 spaces to the left and 1, 2, 3, 4 up. And here's our graph of our quadratic, also known as a parabola. To finish, we need a little bit more practice on this, but we can use this as well to find our turning point in our transformations, just like we did on the previous 4. It says write the following quadratic equation in vertex form. State the vertex, the transformations that occur to the parent function when we get down there. And we still need the practice on this. We're going to start by moving the 1 to the other side. And again, I like to write 1 plus y. You might write y plus 1. It doesn't make any difference. There is no number in front of the x squared term, so we don't have to factor it out. So we can go straight into completing the square. Complete the square here. We need to add whatever we added on the right side over here to the left side. To figure out what goes in that box, we're going to take 10 divided by 2, which is 5 squared. 5 squared means 5 times 5, which equals 25. That's what goes in the box. Sorry, cannot get the 25 in there. Try this again. 25. Move it up. And then box. Alright. So now that we've got that 25 plus 1 is 26 plus y. And I'll even skip some steps here. I'm going to go straight to the factoring. The thing about completing the square is that these parentheses have to have the same values. X squared is x times x. 25 is 5 times 5. The sign in front of the 10 is a plus, so these both have to be pluses. And now we're going to condense it down. So we end up with 26 plus y equals x is 5 squared. And lastly, to write this in vertex form, we're going to move the 26 over to the other side by subtracting 26. We get y equals x plus 5 squared minus 26. That's vertex form. Once we have it in this format, we can identify our turning point. Change the sign, keep the sign. In our transformations, 12 plus 5 tells us that we're going to move left 5. Minus 26 tells us that we're going to move down 26.